Hello mga sangkay, good morning. Welcome back to my tutorial. So I'd like to introduce to you this topic. This is about velocity and time graph, calculation of the distance between 2 points, and then most likely accelerations between distances or between points. For example, you have your car accelerates uniformly from rest to 5 meter per second, okay, in 20 seconds. So this is, should we say, from 0 here, 0, and then 5 here. Okay. So that is in 20 seconds. Okay. From here, this is 0, and then here is 20. Okay. So after which the speed remains constant for 30 seconds. So here first, from 0 to 20. Okay. From 0 here to 20. Sorry. From 0 to 5, I should say. Velocity of 5 in 20 seconds. Then after which, there is no movement of the speed, or there's an increase in speed. It remains constant. So the acceleration is 0 here. Okay. There's no increase of speed. Still, it's 5 meter per second. Okay. Then the car starts to accelerate again. That is from 5 to 7 meter per second. Okay. So you have here total time here is that you travel constantly of like 30, okay, 30 seconds. Here, time here is 20. And then it increases from 5. Here is 5. And then here is 7. Okay. Then that is around 15 seconds. So total here, the time that the increases is 15 seconds. Time consumed, so that is as a total time of 65. Then after which the speed remains constant for 25 seconds. Another 25 seconds. Now the velocity remains at 7 meter per second. This is still 7 meter per second going here. There's no increase in speed. Okay, that's a total of 90 seconds. And then from there on, you decrease the time for 10 seconds, decelerate to rest, meaning 0. Okay, so this is 10 seconds. Okay, this would be 10 seconds, and the velocity here is 0, 0. So, okay, so that is total of 100 seconds. You have the 5 meter per second velocity under 7 meter per second. Now, the question is to plot the speed and time graph. So this is actually now the speed and time graph, the one that we did. And then now let us try to calculate distances. But first, let us try, okay, the accelerations, or the acceleration for each, let's say, area. We could divide this into parts so that it will be easier for us to calculate for the area or the distances. Obviously, the value of the area here is the distance. Okay, you compute the area 1 is the distance from 0 to 20 seconds. Okay. You compute the area 2, that's the distance from 20 to 50 seconds, which is a total time of 30 seconds, and so on and so forth. So let us compute the acceleration, for example, from O here to, let us say this one is A. Okay, so what's the acceleration? Acceleration is just the final velocity here, which is 5, and then the initial velocity here, which is 0. Okay, so you have here 5 and 0, and then the time consumed is 20, so you have here 20. So 5 over 20, okay, that is the acceleration. Just do it with your calculator. And then obviously for from time 20 to 50 seconds, or total time of 30 seconds, there's no acceleration here, so obviously that is 0. Now for BC, for example, this is B, and then this one is C. So the velocity here, final velocity is 7, and at B, here at B, the velocity is 5, which is here, right? So you have 7 minus 5, and then the total time here is 15. Okay, so you have velocity over time that becomes meter per second squared. Okay. Then CD, for example, this is your D. Of course, the acceleration is zero. There's no change in velocity, so acceleration is zero. Now, its velocity is not changing. Okay. Now, O from D to, let us say this one is E. Of course, this is deceleration, meaning it should be negative. Okay. The final velocity here at rest, so meaning that is zero, this one, and then the initial velocity from which the brake is applied here is 7. Okay. So the total time is 10, then you got here a negative 0.7 meter per second squared. Now, how are you going to compute the distance? This is just the area of the triangle. Okay, the total height here is, actually, that one is 5. Okay, so you have here the distance. For example, this is for 1. Okay, 1/2 base, I should say, base times height. Okay, this is the area of the triangle. Base is 20 seconds, height is 5 seconds. So you have this one. Okay, and number 2, see, for number 2 here, for number 2, this is just a rectangle, 30, and then the height is 5, so that's why you have 30 and 5, and so on and so forth. Number 3 is also rectangle, this is 15, and then the height is 5. Okay, so this is number 3. Okay, and then number 4, it's also a triangle. What's the height here going here? This 7 and 5, so meaning this is 2. Okay, that is 2, the height of this triangle 4. That's why it's 100 base here is 15. Okay, and then height is 2. Okay, and then you have, this is area at 4, and then you have 5, it's just a rectangle, total height is 7, and then the base is 2 and 5, and then this one is a triangle, total 1/2, of course, area triangle is base times height times 1/2, base is 10, this is seconds, and then height is 7. Okay, 7, this is from here up to here. Okay, so summing up that one, you could get the total distance. I hope you could do your part, get your calculator, and you can check the total distance. So that's all for this velocity time graph. Hope to see you next time. Thank you.